We now look forward to our first keynote address. Students, please be seated. Our first keynote address on ANN-based wind and SPV power forecasting by Professor Dr. S.N. Singh. Sir, I request you to proceed with the keynote address.
How to go back? Yeah. Okay, good afternoon. And I can see here most of the people from the IT and computer science background. So here I'll focus on mostly on the computer science area, or you can say AI area. But the application here, I'm going to talk, that's how we can forecast the wind. In the wind forecasting, there is a two aspect. I can forecast the wind speed, or I can forecast the wind power which is coming from the turbine, which is already you can see the coastal area, a lot of wind turbines are there. So the two aspects are there. Similarly, in the solar, I can directly forecast what is power output as going to be these solar farms, or we can forecast the irradiance, and that basically using the machine, or you can say manufacturer's design, I can get the output. So in this, the artificial neural network is basically used. And we all know this artificial neural network has a lot of versions, lot of varieties, and also at the same time, it was having the different names are basically used for the artificial neural network. No doubt the artificial neural network was invented long back when the 1946-48. It was basically the people thought, always I say, that you have to be very thought-provoking. So they thought if my mind is working so fast, why not we can have something same nature, we can have some model and we can apply, it can solve the problem. We know in the brain of person, they are having the millions of neurons, billions of basically the interconnections. To know this, the conceptual idea, you know, a baby bonds, even though pinch it, never cries. But the way it is growing up, even though whatever the pinch, even the mosquito cuts you, then you always know where is there and how much magnitude is there. How come? It is through our ages, through once we are growing, our neurons are trained in such a way to identify the location and the magnitude of any impact on your body. And that is known as the training. So in the similar concept, people said, oh, there is millions of neurons, no mathematics, how much it is there. So, but when they're taking a small mass, they found by this, and based on that, they calculate, oh, it is billions of the neurons are there in our mind, and they are connected. Even though something happens here, sometimes you didn't notice. Means there is no activation so that you can identify. So all this philosophy were used to basically make neural network. So your neurons are make as some here neurons, we have the artificial neurons. The interconnections, all the neurons are connected. We have the interconnections. And there is a gap which is giving us some voltage, something clicking point so that you can identify, you can do, that is basically known as activation functions, and learning over the period. It was working very well, but again after 1 hour, unsupervised learning, it may be reinforcement learning. Now we are talking in that deep learning and so on and so forth. So the learning, always we say the machine learning as well as the AI is very popular. So the learning phenomena in this basically introduced, and then we found its beauty in the predicting or doing in the different aspects. So the neural network is very good for the forecasting. You remember, I think all faculty members, just 20 years before, we said the supercomputer is coming from US to forecast our weather. Why we need supercomputers? Because the data processing, now it's all the computers are supercomputers. Because again, how many parallelly processing and doing all the things, you know very better than me. So using that, the supercomputers, because the data and other things are very, very complex, and large data we are processing so that we can very quickly online, we can get the information. And that is basically the computers were used at that time. We brought from the US. Now we are basically having, CDEC is having a lot of high performance computing. Normally we are calling. We are not calling supercomputer because the phenomena and definition is changing. So we are saying high performance HPC we are buying, even though CDEC is giving the HPCs. And also we are having the different countries are also across the globe, developed countries, they are having the HPC, and there we are doing the forecasting because the data is there. You see how much it is changed. There was a time when the forecasting from the radio you were listening, at that time TV was not there. So it was giving the forecasting that it will rain today or maybe tomorrow. So there was no rain on that day, today and tomorrow, at least it was not raining. But now you can see they will say rain today, it will certainly rain, even the one drop of water will come. That accuracy has achieved. The forecasting is so accurate. Now you can see, using the AI model, now even though election results are forecasting, even though our general elections of the parliament, the AI, the forecasting was very close compared to other forecasters. Those were the survey based. So now you can see how much perfections are coming with the neural networks or AI, I say, because the AI is a branch where the neural network is one part. So using all these things, basically the forecasting is very, very challenging. And also we require the training, data, a lot of learning technologies that people are developing, all the computer science people are developing, so that we can match very perfectly. So doing all these things, as you see, that we also started forecasting for our application in the electrical engineering, and the wind and solar is so important that, always we want to use these powers in our system so that we can save our environment. Always we say green computing. What is the green computing? It is nothing is a computer or electron which is flowing, or what is the signal is flowing, it is a green, red and white. No. The signal is colorless. So once we say green computing, means you are doing the same computation with the low energy. Means you are saving the energy. And if you are saving the energy, means you are saving energy, even the small 1 kilowatt here, even 1 unit of energy here, you are saving more than that which is generated somewhere at the power plants. So the government is trying, that's how we can trap our natural resources. No doubt, coal, oil and gas, nuclear, they are also natural resources. But they are either on surface or under the beneath. But these natural resources in the top of the earth, like wind in the air, sun is in the air. And they are abundant in our country. Wind is very limited in our country. Why? Because our sea is very deep. If you go in Europe, they go 100 kilometers in the sea and they are having the wind farms. because their sea is shallow. Our is so deep, I cannot put because it's not feasible. We can put a tower base, etc., but it is so expensive that what is output you are getting, it is of no use. So we are basically more relying on the solar. And that's why the solar mission of the government is so massive that why not we can use. So every time we are keep on adding this solar in our country, and wherever it is possible, you can see rooftop, solar, even the farms are there, all the things, we believe the 300 days are basically clear sky days in our country. On average, I'm not saying go in the hilly, come in the Pune and other areas, keep on differing, but in the totality it is there. So that's basically there. I can tell you even though maybe here it's not very important what I'm going to talk here for you, only except the AI, but there is a Abdul Kalam ji told in one of his lecture, there may be day that just like we buy the milk every day for the house, we'll buy energy every day for our house. Means not buy like wires, just put the energy storage as something. Now you know the battery, there may be a socket that's for energy that will be sufficient for 24 hours for your house. If this problem this is basically invented, then we can develop these cells in the third digits from the solar. We can use the Sahara digits. And a small area, 250 square kilometer, if I can use to tap that power, this will solve the energy need of whole world. So who knows? Because always that will be the invention, not innovation. And people are keep on trying to develop. Now you can see the solar these batteries. Earlier, how much it was there? Now we are having in the mobile, you are having the batteries. How much it was taking charge, and now even though many, we are already, your internet is keep on running, still it requires 1 day's charging or 2 days charging. So that technology in the battery side is moving so fast. If it will be happening, then I'm sure, right now still electrical engineering is the second in the branch in the institutions, that will be completely stopped and closed. Because only then building engineering will be there and wiring, etc. needed. If that technology will come. So they don't know which technology will coming and which engineering branch is going to be swept. With that, nobody knows. That's why I say just forecast. That's what will going to happen after 5 years or 10 years. So the technological advancement are there. So here, why this forecasting is very important. You know, the first power system in the world came in 1982. And this was the Pearl Street of New York City. In that New York City in 1882, it was known as Pearl Street because at that time they used the bulbs. And in evening, once it was turned on, it was glowing like pearl. And still that street is there in the New York City. And this was the first power system, and it was DC. You see how the technological changes in electrical engineering, many of you will be not knowing, it was DC power was generated at that time, even though AC was not invented. So it was DC, bulb was DC, even the cable was used, and it was giving only 59 customers at that time, and that is straight. Then people realize, oh, it is good. Why not we can tap this one and we can generate more and more power. Then once the power requirement exceeded, then people realize, oh, DC is not good. Because the DC was invented by Thomas Alva Edison. You know, he got the Nobel Prize for inventing the bulb. Not the power system, but he developed the DC power system in the New York City. And it was started moving all across the globe. But once you are going for more and more power, it was found, oh, it is not good. And I can tell you, DC completely dismantled. And AC came at that same time, Tesla brothers, Tesla, Westinghouse, all this they started with the AC. And it found, oh, AC is very good. Because the voltage at generating station at your end is almost same. And we can even increase the voltage of your, even the receiving end. But in the DC it is not. It all play a reactive power. But anyway. So this you can say DC gone, AC came into the picture. Again AC started the voltage rising. Whenever the material science invented. Why I am talking this? It is all the engineerings are interrelated. Now the multidisciplinary started very beginning. Now also today. Not only the coding. You have to now, any product you are developing, it is basically a skill of all the engineering. If you are going to develop a simple chip, simple any device, anything, it requires many things. All the engineerings are basically applicative. So there, from the AC, once you started the voltage, because the power demand is very high. Even though one time, there was competition between AC and DC, because some, like Thomas Edison Edison said, oh, DC is good, AC is bad. And the Western House saying, no, AC is good, DC is bad. Even though Thomas Alva Edison told this AC is used to kill the people. Why? Once the AC was invented, it was given the socks to the robbers or criminal guys. You know, the AC, it will be, people will start sicking. In the DC, it is stick and person will die. But you know, always beauty is beauty. And it was found this AC is better compared to the DC, and the DC dismantled, completely disappeared, and we came to the AC. Now again, once we started the voltage level from very small voltage to we reached 1100 voltage, 1100 kV voltage in the transmission, generations, also voltage increases, utilization voltage, we went. Then we realized, oh, AC has also a problem. Then people started thinking what to do. Then we found, oh, how it can be fit for the today's environment. So now we are having more DC and less AC, and so on and so forth. Similarly, for any technological development which was obsolete long back ago, now may be useful today with the certain changes, with the certain. At the same time, power electronics came. At that time, chip devices and chips, etc. came. Huge. Computer came. All the technological advancement basically led to different directions, and that's why we are standing here. So the technologicals are basically always moving. It is there. So that's the artificial neural network is basically used for the forecasting of the solar and power. Now, you know, if the power is not there, everything is closed. Your mobile will be discharged. Just you see if let's suppose for 2 days electricity is gone, you see what will be the status. Even though in this building, let's suppose electricity is gone for half an hour, everyone will come out from the room. Although whether they are using computer or not, they are having mobile and other things in there they can use, but still that's basically our psychology is in such a way that we need the power. No doubt, once some computer guy will come and he will talk about this, he will say computer science is only without that you cannot survive. Everyone will talk about it. Always people say, no, my curd is sweet, others curd is sour. That's, I'm also telling this. But just realize, if electricity is not there, will you run anything? Everything in collapse. So this, here once power system which was growing in the 1882, that time we started the forecasting. Why? Because the consumption of power in your hand, generation person is sitting somewhere, you don't know whether you are using or not. I'm going to turn on a switch, I never take the permission of here from Pune, the supply company. Never. So once you are increasing the power, you are utilizing the power, that should be matched from somewhere, and that's always the frequency is one of the component. So we were doing the forecasting. I can tell you the highest wind is in the Tamil Nadu, or highest load setting in the Tamil Nadu. The region is wind can go off in 15 minutes. And in 15 minutes, no generator can be started except your pump set, or you can say simple diesel generators or small generators. So thermal generators require minimum 2 hours, minimum 2 hours. If it is already hot rolled, otherwise it requires 6 to 8 hours. By that time, what will happen? We have to go to a load setting. And if you have a very well forecasting of this wind and the solar, we can manage our generators in such a way that I know that after 15 minutes or 1 hour it is going to be off, I can be well prepared so that I can give the power and there will be no interruption. There was one time, there was in 2012, there was major grid failure where on 30th July, the northern region, several 17 states, including Uttar Pradesh, Madhya Pradesh, all top, they were in the dark. Grid was failed. In 31st, again, there is the three region, complete northeast, that is your eastern region, like Bihar, West Bengal, and the top of the Delhi and other Uttar Pradesh was dark. Three regions. All the trains were on the road, on the tracks, stopped. That was major. What happens? A small device, which basically unintentional operation. Why I'm saying unintentional? I'm not saying mal-operation. There was a huge debate on this issue. This is a mal-operation or unintended operation. What is the difference between these? You see, both are same because it should not operate, it operated. And the grid was failed. So there was a task force of the ministry. I was a part of that. The person manufacturing relay said, no, it is not mal-operation. It was unintended operation. Because the relay was made to operate for that condition, it operated. Why you are saying mal-operated? Mal-operated means it was not intended for the operation, it operated. Means there was no condition, but it still operated. And that huge loss. And then we try to thought how to give and save our grid. And you can say now 13 years, there is no grid failure. So it is always this electrical is so sensitive and it works in the seconds. The phenomenal, it's no manual control, the grid. So it is interconnected. Huge, more than 400 gigawatt capacity we are having in our country. Huge lines. Always, even though small city, you can say one transformer gone, one feeder gone. This is very small things. If the big is gone, nobody can save you. So this forecasting started long back. And once we are integrating the wind and solar to have our green energy generations, even the people are saying, oh, use electric vehicles. It is now electric vehicles or hybrid vehicles are very common nowadays. And government is giving a lot of subsidies, a lot of promotions for the electric vehicles. The batteries, basically now it's very sustained, that can go for more than 300 kilometers, even the many batteries. Some are going up to the 550 kilometers. Again, the cost, etc. is there. So that people are saying use electric vehicles, environment will be clean. It is so? It is not. Because the electric vehicles is basically the power which is used by electric vehicle is coming from same thermal power station if it is coming, which is emitting emission. Only what is happening, your city pollution is gone somewhere else. Just you can imagine the same which was burning for the low efficiency thermal power 28% to 20 to 28%, this your petrol engines was approximately 50%. More than that, which was using, so you can see the efficiency. We are very less efficient power generation is coming to you. So more coal, more emission is coming. But since in the cities, once they are running, so it is a burning and CO2 emission, all the greenhouse gas emissions are coming from the transport sector. The government is saying, look, go for electric vehicles. At the same time, we are generating these powers or some other locations that can be utilized. So in the totality, the environment will be clean. So this is basically green power, that is generation is needed, but it has a lot of challenge. At the same time, it has many issues, even though all these are, many are technical, many are non-technical. Because always you can say solar panels are in the air. Because if you cover it, no solar air radiance. Wind turbines, always they are on the air. So they are facing the huge environmental constraints or pressures and stress on those things. That is another challenge. And that's why you can say many times we are roaming around, you can say many turbines are basically stand still. And many times you see the turbines are rotating very slow. But reality it is not slow, because that is rotating, we are having the gear system, and finally our generators are generating at that speed and we are getting the power. So they are our temperature variation in our country and many part of our country is very extreme. Going with the negative with the 48 degree. Huge stress. Our environment is not very clean because due to the constructions. I was told the Pune will go everywhere, you'll find the constructions are going on compared to other cities. Yes, because if they're going to be developmental stages and also the need and other things, societal need is there, it will be there. So that dust are coming on your panels, so we are cleaning the panels. So every 2 weeks, it is basically cleaned so that we can get maximum output from these power. So the various technical is there, I'm not talking about that, but the certain other things like maintenance, other things, small devices are there, electronics devices are there in solar panels, power electronics are there in all these devices. So we are talking about the converters, those are, again, we are talking smart converters. So what is the normal converter? What is smart converters? What is other devices, those are there, that is basically of another concern. The forecasting is, in general forecasting, is always the same. There's a two type of forecasting. One, if you are not having the past data, then what we do, and I want to forecast. For example, I want to see what is the economic level of this society. If the data is not there, so I'll go for the field survey. Like in election, the forecasting they do, they take the feedbacks, all their agents are there, they keep on putting the information based on that they predict. Also, they use the past data. But many things, if you are having the past data, for example, here there is no, what is the temperature was there yesterday, if you have not measured, it will not work on survey. So we normally take the past data and the current data. Based on that, we can forecast maybe the next hour or maybe the several months or several years. So that is the forecasting, the basic principle. The fast measurement of past data are used to forecast later. So it is a 1 hour ahead, maybe the 1 week data information that I'm predicting, or maybe monthly or yearly, or going for several years. So depending on that, we classify short term, long term, medium term, many terms. That is basically for, it is not here, it's for everything. It's not electrical engineering, it is normal forecasting. And forecasting is very good. What we do, sometimes we go to the see our kundalis. Sometimes we go, bhai, dekho bhai, mera haath mein kya likha hai? It's very enjoy it. That's, we want to know our future. So we go for the horoscopes. Also we say, go to the palmistry. If you are in the problematic, then only we go. Normally we don't go. If everything is normal, it's fine. But if you are having certain problems, so then we'll see some graha is coming and is doing his bad impact here and there. So always this is very good, even the elections. Everyone turn on, that's what is going to happen. So that is basically, it's not a forecast, it is a prediction. So it is a very minor difference because that is a survey based, and also the past data, basically small swing creates your wrong results. And that's why you can say the general elections in 2024, you found that's it was wrong. Only the AI predicted approximately it will be 300. It was for the 300 with the NDA. So that basically is a very challenging task for everywhere, and predicting the behavior of people. They voted somebody else, they are saying I voted somebody else. It's very common. They never disclose. But they will ask many questions. Based on that, the people extract, okay, what is the tendency of this guy? And predicting the nature, even the more difficult. And this is the wind and solar is nature based. So that's why it is the AI tools are very good. No doubt we had the conventional methods as well. This is basically related to the electrical. Earlier we were only forecasting the load. What will be the load next hour? And that is depending on the past data, because it's a pattern of the usage of any individuals are known to me. And based on that, I can predict, okay, maybe there will be surprises, there may be outliers. It is always there in any predictions. But based on that, we can say, look, my load profile is there. So the load we are doing, now we are having the renewable energy sources. And to your surprise, many here electrical people are not there. You know, every 15 minutes, the electricity price is changing. Although you are not affected, it is done by the utility and they are buying on for you. But this is decided by the state government that this will be the price and that we are paying for that. But at the higher level, industrial level, it is the Every 15 minutes price is changing. You'll go in the England, it is every half an hour, normal users are also, the price is changing. So now it is started trading, market, another business created. So this is enormous change in all the areas of engineering and the technology that is happening. So the lot of advantage I should not talk. And that will be directly related to management of whole grid. Otherwise, grid is huge shortage. Certainly, even though in the 1 hour there is a 10,000 megawatt power is gone from these renewable energy sources. Then the utility, the grid India, how they are managing this, you can see the operators, they will just run here and there, ask all the generator, please turn on and try to get as maximum as possible so that load setting can be minimized. But still many times the load setting is done and you not knowing, you'll always abuse government bijli nahi de raha. So many concerns are there in those things as well. Various conventional methods for forecasting, it's a long back history. It will there various like your auto-regression model, auto-regression moving average model, various technological models were there for the forecasting. You can say fractional ARIMA, various methods, but there were a lot of, they are the linear regression models, mathematics was there, it was not good to capture those things. Then nonlinear regression model came, and this was basically when the neural network came, people started using this. And it was found is the best approach compared to all the previous approaches, and that people started for not only wind and power, for all the area of forecasting. Normally, it is a artificial neural network are used for the forecasting. So the now AI is the neural network base, and you can see it is again the regression model. Various other models were also basically utilized. You can see here, this is the very random and the wind forms are there. Always you can see that is there here, this is the wind speed, but you can see speed is higher, but output is low. Because there is a cutting, minimum speed, and the minimum and the higher speeds are there where the wind turbines never allowed to rotate because due to the various pressure exerted on this. So various methods, or you can say statistical methods and other methods are there. Here, one thing what we did. Now, what is the technology and technical part we developed? Here, one we use two-stage model of the forecasting. One is directly you are having a artificial neural network, give the inputs, output is there, you have to train before with the past data, and then give the any new inputs, output will be very clearly and very fast we can get. It's very online application we can get. So this was basically done for many, many years. Then it was found because there were the spikes, you cannot capture very clearly. So this we basically devised the two approach model. One is using this AWNN. Now coming to the various model of neural networks. I don't know, I have this. No, I don't have data. Yeah. So in this adaptive wavelet neural network, the neural network, there is a neuron. And at the neuron, we normally introduce the non-linearity. Earlier, we were using the tan H function or sigmoid functions at the activation function. It was a normal neural network. Later, we started using the Gaussian function at the activation. You know, Gaussian function is the Gaussian function, the PDF file you know, Gaussian distribution. So that was used, then people started calling as radial basis neural network. Now, instead of that, if you're using the wavelets, you know the wavelet transforms, and we are having various mother wavelets, and that we can use, I think electronics people might have studied. If you're using that wavelets, so it is giving very effective because it's very highly nonlinearity of the system can be mapped and modeled. And we use that one, adaptive wavelet neural network. It is advantageous in that sense. It has the two parameters. One, you can stretch the wavelengths, so that is the time dilations, and you can say A and B parameters and peak you can reduce. So that you can change during the training, you can have that activation at the neurons, and that basically used, and that is known as a wavelet neural network. So we use the wavelet neural network in the first stage, but in the second stage, we didn't use the wavelet neural network. Now you can say, why not? It is so nonlinear, use this. We found it is not giving the proper result. The reason is that once you have taken the nonlinearity, there are something linearity also. So even though your nonlinearity, your mapping is going to be nonlinear mapping, and it creates a lot of problem. So we use this feed-forward neural networks, normal neural network, and this combination of two, we forecasted and we found this giving the best money. We published one IEEE transactions on this work. And so this, what happens, this is the data of years. We took, for any model you are developing, how do you know this model is correct? So what we do, that any past data you are having, so you take some of the data for your testing or validation, and the remaining data for the training you can use. So the some data is used here, and based on that, you can say, once I expand it, stretch it, now you can find this trajectory. Now you can see it has no relations how hazy it is information, and I want to match it very clearly. It's very complex phenomenon because the wind turbine, wind is keep on moving, directions is changing. It all depends upon nature. So another here in the neural network, that's you have to have that which time of the data you have to take the past. Past you have millions of data. Which data you have to take, and that data mining is another concern that is a part of the computer science. So we go for the correlations. I think many of you will be knowing the cross correlations and correlations are used to pick up the data from all the millions data, because all the data are not required. Otherwise, if you are using all the data, you may get with the non-optimal solutions, and also you stuck and you will not get anything output. Your forecaster, another thing will not work here. So we have to also do this auto correlation and the cross correlation, and we forecasted here this hour ahead wind speed first. And once wind speed is forecasted, we cancel it. Slide. No, escape. Okay, thank you. Another what we did, that series you saw, because this is the variation of the wind speed over the time hours. Now, this is looking at some signal. So, you know, multi-resolution analysis, what we do, we use the wavelet transform. And what wavelet transform does, that it's creates in the bands of the frequency of the signal. So the various levels of even approximate and the detailed, so the wavelet transforms were used, and then you can see the signals are divided in the different frequency range. Why we did, it was found that for each range, for here if I can have another neural network, for this we can have another one, for this we can have another one, and then later we can add together, I can get the correct. And that's the scale we use, and it was giving a very correct result instead of using directly this is the input. So instead of one neural network for this forecasting, we had many, and that was basically added together, and then it was found is giving the better result. Now the question is how many levels you can go. There's no end because the frequency here is thousands kilohertz, and that's basically very, very normal. So you can see once the signal has come up to certain hit and trial method, we went for the 7 level of resolution, and that was giving the better result. So you can see the signal was basically broken, and for each one we are having a neural network, and the later we added together, and that's basically giving the better forecast. And that's basically we have published this one. So already we do the autocorrelation for input selections and cross correlation for this. You can see for each neural network also, like your inputs are different. Again, it is how it is decided. It was basically using the correlation factor, autocorrelation. And from there you found, okay, this variable, this our data is more effective in my output, and based on that it was taken. So you can say this is the input is 4, here is a 4, here is 7, here you can say 11, here is a 13, and so on and so forth. So that basically done by the autocorrelation, and we used for the AWN, these are inputs, and for the feed forward neural network was this, and using this we found our results are very good. These are the bench models where we compare our results and we say it is good, and we forecast it with this. You can see here the black is actual, and your red is the forecast by AWNN, and the green is forecasted by FNN. You can say green is giving less result because it is a adaptive Webler neural network is speaking, is very close, it's a sharp right. Because that is, if it is a flat, any neural network will work, but for the non-linearity purpose, it was given, and you can see how it is once is very obvious. Right now, I am forecasting next hour, what will be the temperature, what will be my speed, etc. is very clearly I can forecast. But once you are increasing for the 24 hours, you can see error level is increasing. You can see is the time hours is going 30 hours. The error is increasing, and we have to see how much we have improved upon from the existing models. And you can see once you are very closer, it will be very closer, and always you can see using my model here, all these things you can get it better compared to the persistent model and other model, and based on that it was forecasted. Similarly, it is in terms of improvement. One was in terms of percentage improvement. You can say it is going to be better in the beginning. Later, it is going to be not improving, much lower improvement. So lower improvement is bad. So in the beginning, it is giving a better result also. So then we developed another model. Here is only using the wind speed. Then the two-stage model, here we are using your wind speed taken, wind power taken, and then based on that, you can see here, the wind speed I took, then I use one neural network. Here the wind is, the output of this is the forecasted wind for the next hours. So that using that, and that is basically with the power added together, and it was giving better power output. Because that is my main intention is not wind speed, nothing I want, what is my output from the wind turbine. I can get it, so that basically we did, and you can see it is giving the better result compared to even the previous one. So these are the comparative results. Similarly, we did for the solar panels. This is the architecture where we tried. Here you can see we also had the similar analysis, but the inputs, another, all the analysis like ACF, another thing with model. And finally, we basically got this one of the panel, the 375, we got and we did, and we can see the result I'll be showing. We use the adaptive neural network in only one stage, and you can see our forecasting is coming very close with the AWN compared to the feed-forward neural network. These are basically the variations. You can see how much, if it is all the dots are very close to the straight line, means it is a better. You can see with the scattered means these are the errors from actual. And that is the variations are shown. You can see with the adaptive neural network, these dots are very close. Of course, forecasting will be there will be error. If it is exact one, it is not a forecasting. Forecasting will be always having errors. We want the errors should be very minimum. And if it is keep on improving the errors, that the model is the best model. So that's why it was tried and for various days. So we, again, you can say AWNN is the dense, so error is minimum, so on and so forth. So this is basically the forecasting we talked here. If you have any questions, I think already 1:31. So any questions you are having, welcome. Otherwise, thank you very much. So I'm sure here I don't see the electrical because this institute is IIT, but the usage is the computer science. That's why in my inaugural I said that I'm not from AI and other things, but I utilized AI long back using here. So I'm one of the user, and we are doing a lot. This forecasting is used now in the Ministry of Power for the forecasting. So that's basically the beauty that we have implemented and we have given to the other state electricity boards here and there. Okay? So thank you very much. Thank you all.
Thank you, sir, for your deep insights and I would say relatable examples in the prediction and forecasting and its different approaches. So thank you very much. Moving ahead, let's welcome our second keynote speaker. Our second keynote speaker for the day, Dr. Manasi Patwardhan, Principal Scientist at Tata Consultancy Services, Pune. She would address on the topic Research, Code, Food and Fashion. I would like to introduce her. With over 15 years of experience in natural language processing and machine learning, Dr. Patwardhan has an impressive track record of patents and publications in top-tier conferences. Her contributions have earned her the prestigious A grade at TCS, along with the TCS Innovista Award and the Young Engineers Award by the Institution of Engineers. Prior to her industry tenure, Dr. Patwardhan served as Dean R&D at VIT Pune, where she led funded research initiatives, fostered industry collaborations, and guided PhD and MTech students. We would like to felicitate her. I would request Professor Madhuri Reddy, ma'am, Vice Principal, I2ITCON, to felicitate ma'am. Thank you. Am I audible like this? Even people at the back can tell me? Okay. No, that's fine. Okay, maybe I can have it. Oh, I don't have the USB port. Okay. Okay, so good afternoon, everybody. Um, I have been working in this domain of AI ML. So nowadays they call it Gen AI also, right? Earlier they used to call it machine learning. Prior to that, there were AI, right? Data science and big data and so on and so forth. There are like same person wearing different clothes, right? And whatever sense, that's the name which has been given. Which may there was deep learning. You must have heard about these terminologies. So I've worked in all these things at various phases in my career, and I've enjoyed working in this particular domain because it requires a lot of mathematics, and I love math, and also I love research. So most of my career has been in research. So that's the first term which you can see over here, research. You must be seeing a lot of, there are four terms which kind of research code fine, but the other two terms, food and passion, you must be wondering how they get along with each other. So all these things are my passions, right? So I love research, I love coding, I love food, and I love fashion. So all these things are what I'm passionate about, and I've been really, blessed by getting to work into these domains. So I've applied machine learning, deep learning, and now generative AI to all these four domains. And I'm going to talk about the kind of problems which I have solved at TCS Research very recently in these four domains. So that's what is my talk is going to be. I may not dwell down into the approach which I have taken. If you're interested, I have to go to my Google Scholar. Each of these things which I'm going to talk about is published work. Otherwise, I cannot present it over here. So you will be able to see the papers which are relevant to these topics over there. So I'll start first and foremost, and which is going to take maximum of my time today is about research, because that's what I do for living, and also I'm passionate about, to be passionate about my work. So when we talk about research, uh, we all follow a research life cycle. So I'm sure those who have done research here, they can relate to what I'm talking about. That there is a research life cycle which we follow. And typically these are the stages in the research life cycle, like exploration, ideation, experimentation, codification, communication, and critique. Okay. What do we do in ideation? We basically try to come up with we identify first of all a problem statement. We did do the literature survey. We try to find out the gaps in that literature survey. With those gaps, we define a problem statement. And then with that problem statement, we try to come up with a hypothesis or an idea to solve that particular problem statement. Right? So that's what is the ideation phase. What is exploration phase? When I'm trying to go through the literature, I'm trying to explore for a particular domain what exists out there, and I'm trying to figure out, which part of that will excite me and which part of that I would prefer to solve, or what are the gaps which I will want to solve. So that is what the exploration part, which comes prior to the ideation typically, or it goes on throughout the hypothesis generation phase. Experimentation, you have the idea, you have the hypothesis, you are trying to develop an experimental design for that hypothesis, and then you are trying to come up with some ablations. I don't know whether you have heard this word, but in AI kind of research, we always do some form of ablations. And then there is codification. You want to codify whatever you have proposed in terms of the methodology. You want to basically codify the experimental design and so on and so forth. Then comes the communication part, where you are all this work which you have done, you want to communicate in some form, right? So you want to maybe write a paper, a research paper out of it. You may want to write a patent out of it, or generate PPTs like this, which I'm trying to present what I've done over here. So all these are different forms of communications, right? And
the next part is critique, where I would want my research to be evaluated by somebody who is an expert in that particular domain, so that I will get what is lacking there and I will be able to address those lacunas. Right? So that is what the critique part. So this is kind of a research life cycle. At PCS research, what we are trying to do is we are trying to semi-automate this research life cycle. Now, when I say semi-automate, it means that there will be a set of AI agents who would be doing some part for you as researchers, and then you will be kind of augment those parts by your own expertise, right? So there is a machine AI collaboration which is going on over here, and that's what I'm going to explain as a part of the first part, the research part of my today's talk. So what's the advantage of this kind of semi-automated research lifecycle framework? So we have found out that young researchers who join PCS research or any research organization for that matter, when we hear, or even when I went for my master's in US, my research advisor told me, you basically read a research paper. And this is 2001 I'm talking about. So when I was completely unaware, what do I mean, what does it even mean by reading a research paper, right? And I asked, so I was even scared to ask my advisor, what does that mean? What am I supposed to do? So but still I gathered my courage and I went back to my advisor and asked, what am I supposed to do? What do you mean by reading the research paper? It doesn't definitely mean that I'm just supposed to read the English part over there and maybe even understand it, perceive it. That is one part of it. But I have to go beyond that, and I'm supposed to also understand the lacuna, critically evaluate it myself, figure out where I can contribute. Can I apply that work to something which I'm trying to do? So all these different aspects come when you're trying to read a research paper, right? Now, all these things were taught to us by our mentors, who are pretty busy, right? So sometimes we have to learn all these things on our own. But imagine an AI agent kind of supporting you, guiding you, helping you brainstorm and kind of develop these different, help you develop these different skills, right? So this is what is basically designed for junior researchers, we call them, or young researchers who are just entered into research. At the same time, some of these phases like ideation would definitely help senior researchers who are trying to hypothesize, ideate, come up with new problem statements, come up with new solutions, right? So that's the whole motive of building this particular framework. So now I'm going to move forward. I'll tell you each of these phases, and I'll also tell you how we have, like, what is the research contributions here. So let's first start with the explore phase. So explore phase is all about questioning the literature, right? And when you are questioning the literature is not just about text. It has scientific plots, diagrams, code. So there is a multimodal data, right? So how to analyze this multimodal data, and at the same time, the questions are going to be a lot of reasoning-based questions. I hope everybody here understands the difference between, has anybody heard this term called large language models? Have you used ChatGPT? Have you used DALL-E or any other multimodal kind of language model? Okay, have you heard about the term called LRM, which is language reasoning models? So some of you might have. So let's try to first understand the difference between, like, what is reasoning and just a language model, right? Or what is the difference? What does reasoning mean? So earlier era of deep learning, people started with understanding the neural networks, deep neural networks, and so on and so forth. But they were mainly designed, like you must have heard about convolution neural networks, right? These were designed to perceive data. Now, what do I mean by that? That very basic problem, understanding an image, whether there is a cat or a dog, right? So here, when I'm trying, if I show you an image, and if I ask you whether there is a cat and whether this is a cat or this is a dog, you are not going to address that problem in your mind like, oh, there are two ears here, and then there is a mouth which is shorter, there is a longer mouth in this case, and that's why this is a dog versus this is a cat, right? You immediately perceive that and understand that it's a dog or a cat. Keeping aside some cases which are very near to the decision boundary, cat looking like a dog or dog looking like a cat, right? But you do understand this, you perceive this, you don't reason about it, right? Versus when I ask you a very, very, like any technical question, you have to follow certain reasoning steps, right, to be able to even answer that particular thing. Even a simple mathematical problem, right? If I ask you tomorrow that I went to a store, I bought 12 bananas, I came home, my son ate 6 out of them, right? And then from the remaining ones, 2 of them went bad. So how many bananas are remaining? A simple math problem. We solve this in a stepwise manner. We never come up with a final answer unless you are brilliant in maths. I mean, forget about the small question which I have asked, but when you have some complicated questions, you solve them by following certain steps. Until these reasoning models came up, and still there is a question whether artificial intelligence can really solve reasoning problems. And what we are dealing with here, the scientific literature is all about questioning on scientific literature is all about addressing reasoning type of questions, right? So that is where the crux of our technique lies, to be even how to understand and how to even resolve these reasoning type of questions. So for this, we have come up with, so how many of you have heard this term called RAG? Have you heard about this term, RAG, called retrieval augmented generation, right? So, you must have heard about vector data stores and so on and so forth, right? So these are pretty much now predominantly used terms in computer science. So we have developed something which we call it as SciRAG. And what it is all about is that when a question comes to us, when I am as a researcher trying to answer that particular question, how do I address it, right? So we basically try to mimic the exact workflow which me as a researcher would undergo. So what I would do is I will do first the guided synthesis, right? What does that mean is I'll first try to decompose the query into subqueries, right? And once I have the subqueries, I will try to follow the retrieval in an adaptive fashion, where I'll try to find out the articles which are going to be very useful for the subqueries, right? And then for every subquery, I bring in the article, I read about it, I find, oh, the answer does lie over here, or it may not lie over here. So I go back and again try to do the retrieval for something else, right? So this kind of adaptive retrieval we keep on doing. And then citation aware symbolic reasoning. It means that I don't know whether you're aware of citation network, right? Where you have papers which are kind of referencing each other. So when you are trying to answer a question, as a researcher, we start with a research paper, but then we realize, oh, this particular sentence over here I've not understood. And there is a reference over there. So you dig down to that reference, go to that paper and again try to understand that. And this chain of kind of understanding will go beyond just one reference, but it may go beyond that, right? So I may have to dig down to the citation network, right, to be able to answer the question. So we have provided similar functionalities as a part of our SciRAG framework to be able to answer these scientific questions. Okay, so this is not a very simple RAG. It's a very elaborate mechanism, and we have shown the results on variety of scientific question answering data sets which are out there, and we have shown that our results are actually better in some cases as compared to the baseline techniques which are very prominent, which are out there. How many of you have heard about deep research? Have you used deep research? Right. So what is deep research? Basically, you query and it fetches things for you. Now, please try to use, if you're not used it, it's a fantastic tool. It will try to answer all possible questions of yours, but at the same time, what it would retrieve may not match if you are trying to ask some scientific questions, because their underlying corpus itself is web corpus. And you know that web corpus could be noisy, whereas published articles may not be that noisy, right? So we have also compared our SciRAG with deep research frameworks, which is by OpenAI. All of you must be knowing who OpenAI is, right? So we have tried to compare our at the top you will see a scientific question which has been posed, and that has been answered over here by deep research. There is deep research by Gemini, Google. There is deep research by OpenAI, right? So all of these, and we compared the outcomes with our own SciRAG. Right, and we found out that our outcomes are qualitatively and quantitatively better than these frameworks which are out there. So this is currently kind of under review work, but this is something which is very appreciated by the community. Right, so this is part of the exploration thing which I just now spoke about. Now let's move on to the next part, which is literature review generation. Now those who are aware of research would know what literature review actually means. But in literature review generation, when you are trying to generate a literature review, you try to basically bring in articles from various different places. You put them in a more summarized format. But when you are trying to manage those summaries, you are actually trying to develop more section, subsection oriented, hierarchical summaries of research articles, right? It might be a possibility that one article you are going to use in different sections with different contexts, right? So how do you even do that? That's the question. And we have developed a new algorithm which will help you to not just generate monolithic summaries, which are just paragraphs, but it will also help you to generate summaries which are more section-wise and appropriately clustered as far as the information is concerned. And it also allows you to cite one article in two different sections with different contexts, right? So this is what we call it as catalog guided literature review generation, which we have implemented as a part of our framework. The next part is about research gap validation. So what does it even mean? When you come up with a research problem, you are basically trying to, so I'll maybe show a video here. So this particular framework was used in one of the TCS Japan offices. They had a robotic setup where the robot comes up and it asks customer who is visiting the center certain questions and try to find out what kind of problems the customer is facing.
My name is Kira. Welcome to the office. How can I help you today?
So this robot is supposed to ask certain questions to the customer and get information and try to find out what kind of problem that customer is facing. Once he identifies the problem, this robot is supposed to, try to find out if there is solution which exists for this particular problem. Now, as many of you might be knowing who's into research, that the problem which has already solutions doesn't become a research problem, right? So we are actually trying to identify whether it's a research problem, it has already been solved. And if it has already been solved, what kind of solution exists in the literature is something which we try to retrieve and provide it to the customer. The robot actually speaks, it's more of a brainstorming robot who has a chat with the customer and tries to kind of address those kind of interacts and tries to identify problems and try to provide solution. Now, if the problem is not been addressed already, right, then we do something which we call it as ideation or hypothesis generation, right? Now, I will also show you another demo where what goes internally as far as this hypothesis generation is concerned, and it's very fascinating that you may want to use ChatGPT tomorrow and try to ask it very, very researchy questions, like give me solution to this problem, right? And see what kind of solution it comes up with. So there is a solution space, which is very large space. And in that space, the solutions are, imagine those are like data points. And these models are capable of interpolating or even extrapolating in that solution search space, which is the beauty of these particular models, which we have exploited for the hypothesis generation phase, right? So that's what the next part, which is ideation, and I'll directly show you the demo of ideation. I'll skip a few slides. So what is happening here? So a researcher has basically first it enters the problem which is trying to face. Like in case of in this customer robot and setup, you see, this is the kind of a problem which robot has said he's facing. The customer has said that he's facing. Now, this particular problem here is basically in a researchy problem. I don't know how many of you have heard about transformer architecture. Have you? Right. So basically, it's like even one of the authors are from IICT college. I don't know how many of you are aware of it. But it's like a well-known network which has been now enhanced for developing large language models. The underlying architecture for ChatGPT is also transformer architecture. So this particular problem is about transformers and how to enhance that particular architecture, right? Now this particular, once it enters the problem, what we develop here is a solution. So this solution is being given by a bot. not by humans, right? So this is a very, very specific solution which has been given. We also score the solution based on certain metric. I'll tell you what the metric is. The researcher can go through the solution in the customer environment. Customer can understand the solution in the chat setting. Once the solution is understood, the user can actually click on what is there at the bottom, that is basically generate a review, which means it's basically trying to evaluate this particular idea based on certain characteristics. And what are those characteristics? The characteristics are like impact, alignment, robustness, all these different ways we will evaluate our hypothesis. So for every characteristics, as you can see, there is a score which has been given, right? And based on that score, the score is not just sufficient. It also gives you the justification of, why the particular idea is lacking with respect to that particular characteristics or aspect. And once the researcher can read that particular justification, he or she can actually, either accept the criticism or reject the criticism. And based on his feedback, the idea will be refined, right? So that's how this particular framework works. And that's where I'm talking about it semi-automated, because the underlying agents are actually talking to humans, the researchers, and together they evolve the ideas here. So once this particular input is given by the researcher, now the idea is evolved, and as you can see, the score is also improved, right? So this framework actually goes, into a lot of intricacies. You can also retrieve the literature which could be, so ideas should be grounded in literature, right? What do I mean by that? Is that the idea should not be, I should be able to relate that this part of the methodology, this part of the hypothesis has been derived from this paper. If that is not been done, those who are aware of what large language models are, and you must have heard about the term called hallucination. So they do hallucinate a lot, right? And when they hallucinate, they end up giving you wrong outputs. But if they are grounded in literature, the chance of hallucinations have reduced, right? So we ground these ideas in literature by retrieving right set of literature. So on the left-hand side, as you can see, there is a lot of literature which is relevant to this particular idea which has been retrieved, right? Now, when we are retrieving this is also so currently the ACL 2025 conference, which will be held in Austria next week, at the end of this month. So I'm going there to present this particular work. It's been accepted over there. This is one of the top tier NLP conference, and you will find people from Google, Facebook, Meta is Facebook, OpenAI, and all these places. They come and present their works over there. So what we have been, and this has already been cited in couple of, so if you go and look for a paper of mine called Iris, it's already been cited by multiple different publishers, right? So why it is so fascinating? Because the way we are retrieving literature is completely different, right? I don't know whether you have heard about the term called semantic similarity, right? Typically, you try to find out semantic similarity by using cosine distance. Sometimes you also use KL divergence, right? I don't know whether these are all technical terms, but when you do that, you have embeddings of the query and the data, right? What do you mean by embedding? A vector representation. And when you're trying to find out the similarity between two vectors, it actually gives you semantic similarity, not just syntactual similarity. But what we have done over here when we are retrieving, so when you want to find out literature which would help you to evaluate, kind of make your ideas better, you don't want just literature which is semantically similar. You want literature which is going to be useful for your idea in a way it will inspire the idea. So we call it as methodology inspiration retrieval, right? And when we are trying to do that, we have modified the embeddings in such a way that the papers which would be retrieved will not be just based on the semantic similarity. And that's where one of our patent also lies, right? So this is something which is, so though you are just seeing something getting retrieved over here, there is underlying algorithms, protocols which are working, which actually help you, get better and better solutions, right? So this is one of the frameworks, and at the background, there is something which is called as Monte Carlo tree search, which is going on, which is one of the optimization techniques. Every node of Monte Carlo tree search is an idea, and the edges are basically what kind of activities which have been performed, like retrieving the articles, reviewing the idea, and so on and so forth, and the ideas get modified. So this is the Monte Carlo tree which is getting developed. And you can also auto-generate the thing. So you can give full control to the agents. You don't want to interfere. You want to see what agents give you, right? So at the end, the whole system works and you will see the full Monte Carlo tree, which will give you the whole bunch of ideas, and every idea will be scored based on the metrics which I showed right now, and you will be able to fetch the right set of ideas which are going to be useful for solving your research problem. Right? So this is something which is very recently been developed, and I don't know whether you are aware of a lot of conferences, like very recently there is one conference which happened called ICLR, and lot of, I don't know, have you heard about Google co-scientist who does drug discoveries and material synthesis and so on and so forth? So if you have not, please go ahead and read about it. So all these big companies are kind of entering into, going for developing such models which will do hypothesis generation for you. Now I showed you hypothesis generation in AI space, but similarly hypothesis can be generated in material science space, in life science space, where it will be all about drug discovery, synthesizing new materials and so on and so forth. So this kind of framework yet not been tested for other science domains, but we are planning to test it for other science domains also for new discoveries, right? So this is a very, very fascinating work for me, and I'm very, very excited to present this at a bigger audience. The next part is experimentation. So as I told you, experimental design generation is also a very crucial element. And what we have done is, we have studied how to generate. So let me tell you what ablations means for a minute. So when you have a system of components, every component contributes towards your final result some way or the other. If it doesn't contribute, it doesn't have to be there, right? Now that means if you remove that component from your system, your accuracy should drop, right? Or your performance should drop. So ablation studies tells you, if you remove certain components, how your final performance with regards to a particular metric is getting affected, right? So we have generated a benchmark to test how these AI agents can automatically generate the ablations for you, right? So that is one of the works which I have done as a part of experimental design. The next part is codification. How many of you have used Copilot for codification, right? And isn't it fantastic that actually it will give you the results? I mean, your whole assignments and everything, I think it must be already solving for you if you really used it properly. So the point which I'm trying to make is that now, and people do keep saying that, especially that is a problem in India and IT industries, because the coding jobs are going to go away, right? And that is very true. I mean, believe me, please use Copilot if you have not, for Java coding, for Python coding, right? It is almost accurate. Okay, so the coding jobs are not going to remain anymore, and it is going to be really something which we have to be bothered about, right? So the point which I'm trying to make here is that we are trying to auto-codify the ideas which have been generated, and we have shown very excellent results. But however, for certain machine learning tasks, still there is gaps. So what we have shown here, and this is also pretty early, and nowadays research is like moving very, very fast. So whatever work you have done 6 months back becomes obsolete, right? So this is 6 months back, the work which we have done, and newer models have come up, and if you try whatever we have tried here right now, the results would be different, right? So what we have tried over here is, instead of single agent framework, we have converted into multi-agent framework. So there are agents which would be mentoring agents. There are agents which are going to be like they'll act as your coding partners and so on and so forth. And by using this multi-agent framework, we have codified the research tasks. And what we have seen is that by doing this change and using agents based on their expertise, you can actually achieve better results in terms of performance for codifying the machine learning tasks at very, very lower cost. Right? So this was again very appreciated at ACM AIML's conference, and we have got pretty good results over here. So codification is no more something which is going to be left for we humans to code, right? So this is something which is very something to take into consideration. Critique part, right? Now, this is also very exciting work. Last piece of work as far as research is concerned. So, all of you are aware of this game called Tug of War, right? So how does it play? There is a, rope which you are trying to pull from both the ends, and whosoever can pull the other party, that particular team wins, right? Now imagine agents are playing tug of war, right? So there is a whole theory which is called as game theory. If you are not aware of, there's one of the, and this game, we have built this algorithm in a game theoretic fashion. So what we have done here, that there will be two agents, review agent and feedback agent. And what they will be playing, what will be their rope? The manuscript, the research manuscript which is there. So the review agent is trying to provide critical comments about the research manuscript in terms of where it is lacking, both syntactically, and the lacunas is not going to be, so this is not a plagiarism tool. You must have heard plagiarism or plagiarism tool, right? This is not a plagiarism tool which will just tell you that syntactically here things are wrong, or grammatically here things are wrong, or format is not matching, and so on and so forth. It will go beyond that. Like for example, it will tell you that this part of experimental design is missing. You must, go ahead and do it. This part of your methodology doesn't make sense, or the novelty is lacking as far as this methodology is concerned, right? So this kind of feedback will be given by the review agent. The feedback agent will act as a rebuttal. I don't know whether you've heard about the term rebuttal. You write a rebuttal for the review which you get for on your journal and conference papers. So the feedback agent will kind of disagree, or sometimes it may accept the criticism, but sometimes it will disagree with the comments which have been given by the review agent. And this kind of game will go on, kind of a tug of war game between the review agent and feedback agent, until the point they reach consensus in terms of the agreement that this is where the manuscript is, these are the things which have to be improved, and these are the things which are okay in the research manuscript, right? So this is something which we have done, but there was a lacuna here, and that's why this has been published in workshop and not in conference, which we ourselves found out, that the kind of review agent which we have made, so all of you must be aware of what is something called as Gaussian curve or bell curve, the normal curve, right? And your marks are going to be fitted into the bell curve, right? So the bell curve typically, is supposed to be not skewed to either sides. If it is skewed onto the right hand side, it means that your grader is a very easy grader. And if it is skewed onto the left hand side, it means that is a hard grader, right? Which means it's giving you everybody very, very tough marks, right? So we found out our review agent to be very, very hard grader, right? And it was pulling the whole pointers into one side. So through the iterations, when they both are going through the iterations, we found out that our scoring graph is kind of getting skewed onto the one side, right? We are still working on how to fix that, right? So it's also very, very exciting work about the critique part. So with this, actually, I have told you a few things about the research problems which we are trying to solve. I'll skip, there are many more. I'll skip throughout this, and I'll try to move to one last point here about research is concerned, which is about generation of diagrams. Have you used ChatGPT for diagram generation or PPT generation? And how did you find it? It must be doing fantastic job for you, but at some point it might be failing, right? So we have also used these tools for diagram generation, but we have not just used them in just prompt it and you try to get the diagram out of it. So what we have done is we have used like a neurosymbolic approach, where the symbolic part of it are certain rules which will create a layout for the diagram, and then the internal parts of the diagram will be filled by these AI agents. And we found out to be it performing much, much better than the actual just the agent or the ChatGPT, for example, giving out the diagrams for you. Please try to understand here that the diagram will be treated as a code, because I don't know how many of you have drawn diagrams in draw.io or any other tools, and underlying what happens is a code, right? So this is basically nothing but a code generation project, right? And what you will visualize, how many of you might be playing video games, right? Have you guys used Blender, right? So the Blender and the underlying code is Python code, right? So again, generating these, the video games is nothing but a coding project, right? So on the similar lines, diagram generation is a coding project, right? So we have actually worked on this, and we have tried to come up with better and better codes, based on the kind of diagrams you want to generate. The next part is now we have slight departure from research to code, and we have worked a lot on addressing querying or on databases, right? And you must be knowing that in database what you have are SQL queries, right? So conversion of natural language queries to SQL queries is a well-known problem, and that's what we have worked a lot on. It's not that simple. The SQL queries, they are going to be idiosyncrasies with regards to all the databases. So we have published a lot of work, and we have also patents in terms of how to convert these natural language queries into SQL queries by using domain knowledge, the underlying SME, the subject matter experts knowledge, right? So this is also one field which we have very thoroughly worked, and we have used large language models for that. And we have tried to use these models. So I was presenting this last week at Google, and this is the question they had there, that you have databases, but you don't have the existing natural language to SQL pairs to train a model on this task. So how do you address this? So we have tried to address it by using some adaptation and decomposition framework. I will not go into details, but this is also one of the very work which was early presented at ACL 2023. And we have gotten very good results over there. Now, we have also worked in code translation. Have you known there used to exist a language which is called as COBOL, right? Which is still being used in wireframes of IBM. You know, all the transactions, like all these banking systems which are there, the underlying framework is in COBOL. And they are trying to convert those COBOL codes to Java codes, right? And there are traditional tools which do exist for this translation of COBOL codes to Java codes. However, these tools are not going to give you human readable Java codes, right? Because COBOL codes abstraction level is very low as compared to the Java codes. So how do you convert these translations? How do you do these translations is the problem which we have tackled. And actually we have got so we have tried to kind of get best of both the worlds, because these traditional approaches, they use parsers. You must have had courses like compilers and things like that. You must have heard about context-free grammars and those kind of things, right? So because they are based on grammars, they are not going to give you syntactically incorrect codes as an output. But at the same time, the codes will be completely like, you won't be able to make sense out of it. And if you have to rectify the codes, because the codes are not going to be 100% correct, humans won't be able to rectify those. Even Java experts won't be able to rectify those codes. So we have taken a combination of traditional approach and the modern LLM-based approach. And we have evaluated our generated codes not just based on the syntactic accuracy or the compiler accuracy, but also based on the human readability. And we have kind of used best of both the worlds to get very good Java programs, right? So this is about the code-based work. Now, two parts which are remaining is food, which I'm going to very quickly go through. This is just one of the projects which was very exciting to me. So all of you must be aware that in retail sector, where warehouses or you go to these supermarkets, right? Now, this is already taken place in US. Here also is taking place that they have camera placements to detect if the food has gone bad, to auto detect that, right? So we have tried to develop techniques for food quality detection, especially we are focused on fruits. Okay, so when we do that, the main problem, it was not that simple, because we did not have annotated data in terms of how many days old this banana has gone bad, or how many days old this banana is from the time of it has been plucked, right? So how do you even address that particular thing? We don't have annotated data. Experts are not there to sit and annotate that this is 2-day-old banana as far as an image of a banana is concerned. So how do we tackle this problem of scarcity of data, right? So we have used techniques in machine learning and deep learning called meta learning, and basically it is all about developing meta models, right? Second thing is that if you use this same thing and try to do this by using the models like DALI or all the VLMs which are out there, even Gemini, right? You will get good results, but we cannot send our customers' data to these proprietary models. So we have developed in-house models which are much smaller as far as their parameters are concerned, but we have tried to get similar results as compared to what these proprietary models would give, which are very large models, right? So these are some of the very recent works, and it's also published at very top tier venues. Last one, the fashion, right? I'll very quickly talk about this last part. So what we are trying to develop is a fashion chatbot, in-session fashion chatbot, which means that when a person logs in, based on his history, it should be able to recommend its products. You all must be already seen this happening. However, especially in fashion, why it is more exciting, because the recommendations are not just going to be based on what he or she has purchased. Because if let's say I have purchased tomorrow this dress, right? I have purchased this. Next time when I log in, it's not necessary that it will always recommend me dresses, right? Because I may not want to buy a dress anymore. Maybe I want to buy a purse which will go along with this dress, right? So it's not going to be just conceptual level similarity, or it is not going to be just based on the similarity of the attire, right? Or the outfit which you are trying to work on. It's going to be more style-oriented similarity, right? When I talk about style, you all must be knowing there is retro style, right? So what goes along with what? So there is this outfit generation problem, which we have tackled, where we try to find out similarity not just based on the semantics or how the look and feel of the products, but also the underlying style. And we have come up with style vectors, okay, which are a different kind of ways to develop these vectors. I will not go into details again, but we have come up with the style vectors, which will bring in two items together or closer if they are stylistically similar. Okay, so this is one work, and another work is identifying the attributes of these particular fashion images. Now, why it is so difficult to find out by attribute? I mean that this neck is this is a round neck. This has 3/4 sleeves, right? So all these different attributes is not very easy, because it's a very, very fine-grained task. It's much difficult than identifying cats and dogs from the image, right? So we have developed techniques to come up with these fine-grained attributes, and not only that, because these attributes keep changing in the realistic setting. Why? Because people annotate in different, like there will be a new neck fashion which will come up in fashion world, right? There will be a new way of, like I just saw there are detachable sleeves, right? So there is new fashion as it comes up. Our old models which have been trained on some form of fashion attributes are not going to work anymore. So we have applied continual learning techniques. Based on small amount of annotated data, we can adapt our models to adapt new fashion trends, right? So these are few works which we have done in the fashion domain. So as a crux, what I want to tell you here is that this is all from my side, but I would like to kind of conclude with a few things, that technology is changing very, very fast, believe me or not, okay? If you really want to be not outdated, obsolete, right? You really want to be very much abreast with what is going on in the industry, as well as what is going on abroad, not just within India, everywhere out there, right? That means you have to read every day, right? You have to be aware of what is going on in the research field as well as the business field in terms of what upgrades which are happening out there. If you are learning, you must be learning computer science, electronics, engineering, whatever you are learning here. That syllabus is going to be just an iota of what is to be learned out there, right? And that is important. You will have to learn that. It's not like you're going to directly jump and learn something which is going to be completely new. But at the same time, you have to, if you want to be sellable in the market tomorrow, you will have to be abreast with whatever is going on in the current world. If you don't do that, you will be absolutely thrown away. Okay, and this scenario, unfortunately, is changing very, very fast. So my friends, my suggestion to you is, like, especially as students, that you may want to consider this as a, eye-opener at some point in time, and make yourself abreast with the current technology and current, happenings which are there out there. Thank you so much. Open to address questions. Yes, please.
Actually, I have a single question, but there are two aspects. So, first of all, I'm developing my software development is currently based on a lot of AI tools.
Okay.
And I have put my work outside of the things and all. So I'm a little bit skeptic you're using just AI tools to develop something and you're not learning something on your own. So I need kind of a validation from you for that because I think as you said in the codification process that you need to understand that the software engine, software field will be evolving and you need to understand that you need to evolve with it. So I kind of give you a validation and understand what do you think about it?
So, I mean, it's really good what you are doing, first of all, because the first step towards coming up something new or learning something new is understand what is out there. Unless you understand what is out there, you won't be able to learn something new, or even understand whether whatever you are learning is new, right? So, yes, you should use current technologies and come up with. So, I mean, as I told you, AI can be used in like millions of ways to solve millions of problems. And very exciting field, very exciting times right now. And you must use these AI technologies to come up with more applications, products, whatever you are trying to come up with. So that is a check over there, right? But at the same time, I would request you to keep watch on where things are failing, right? Because people do say that AGI is here, right? But that's not true, fortunately, right? So things are going to fail. You will see drastic changes in the industry which are going to happen in the next few years because people are thinking Gen AI can do everything, which is not going to be the case. So what it can do and what it cannot do, you need to understand. And where it cannot do, that's where the research would lie. So keep your eyes open while you're developing.
The second aspect was regarding the research part.
Mhm.
Actually, I'm working on a research paper as well regarding neuroplasticity. So in that also, I was thinking of using knowing what LLMs know about the technology currently available and how we can develop on that. So regarding that too, what's your opinion on using the LLMs or maybe the other tools which are having a lot of data with them? They might create hallucinations for sure. But what do you think about it?
Using LLMs for what?
For research, particularly creating research papers or maybe understanding a market or a survey. And that
Right. So yes, you must use. So that's what this tool is all about. That where all we can use LLMs or the underlying agents.
it's a no-brainer. Like we should do it.
We must use it. Why not? Because if something can be done by AI, why to spend our time on it? We should spend time on something which AI cannot do. You must use it, but at the same time, don't accept whatever it gives you blindly, because it's going to go wrong. That's where the research lies. That how can I verify the outputs of these large language models in an automated fashion? It's a very tough question, very tough research question.
Thank you.
Sure. Yes, please.
Ma'am, actually, I wanted to ask you about the fashion recommendation tool. For example, it has ChatGPT today that recommend something to wear for this particular event and it should be traditional.
Mhm.
The answers become very repetitive. So, how do you tackle that?
So there is something which is called as temperature. Are you aware of that? Okay, this is not temperature of the room. The temperature of the language models. So that's a parameter. If you tweak, you will get diverse outputs. But that you won't be able to do it by using the browser-based ChatGPT. You will have to use their APIs. Yeah. Okay, I think there are no more questions. Thank you so much.
Thank you, ma'am. Definitely, you have given a lot of food for thought for us, for our students also. Thank you very much. We now break for our lunch and then we will resume shortly.